If you haven't seen me before, my name is Rob, but I more commonly go by Bok, even at my work, which is a professional organisation. Still go by Bok because we have, a bunch of other people with very similar sounding names, so everybody knows me as Bok. That's what I am on Slack as well as on Mastodon, everything else. So a bit of background. 3 years ago this month, which is a long time ago actually, I gave a talk at the October 2020 CocoaHeads, which was held virtually because we were in lockdown at the time, about a framework I'd built for managing feature toggles. And the reason I built that was because at every company I'd worked at previously, we always end up rolling our own feature flagging solution. And I was tired of doing that, so I wanted to do something that was solid and open source and expandable. So we did that. I must say though, look how young I look in that. That was only 3 years ago, but I'm guessing the stress of COVID hadn't quite sunk in at that point, so that's pretty good. I am happy to say that I haven't rewritten that yet, but I'm also still at the same workplace I was 3 years ago, so maybe, in 2 years from now when I move on, I'll end up writing another one, hopefully not. If you haven't seen that video, the QR code link is there for the video itself. It's also on the Melbourne CocoaHeads YouTube channel. Definitely worth checking it out, but I will give a bit of background here before we move on. Otherwise, the macro part of this won't make much sense. All right, let me pick up my beer again. So the first thing I want to say is that this is not intended to be a walkthrough of how to build a macro. There is plenty of that on Apple's WWDC sessions, on Swift by Sundal, on Hacking with Swift, all of those sorts of people. They have all of the tutorials up there for doing that sort of stuff. That's not what I'm talking about tonight. What I am want to talk about is how we took an existing code base, thought about the problems that it had, and tried to make them better with macros. Did we actually make them better? We actually haven't shipped it yet, so I can't say for sure, but fingers crossed, it looks like it's going to be a good one. Another goal that we had was maintaining backwards compatibility, which is quite tricky with macros sometimes. Okay. So context, you're going to need some context. As said, Vexil is a framework for managing feature flags. This is how you declare a flag. Really basic. In Vexil, you create a flag container, which is a structure that has all of your flags in it. And then you define any flags you want using the @flag property wrapper. And then you specify the default value of that flag if it's not turned on or off, what you want the default to be, as well as the description that will be shown in the generated UI, which I'll show a little bit later on. If you've ever used Swift Argument Parser, this was defined based on Swift Argument Parser. When Swift Argument Parser came out, it was about 3 years ago, and it did a lot of this stuff, and it did it very well. So we shamelessly copied that for flags. So to actually use that, you create a flagpole, you hoist your, there's going to be a lot of flag terminology references here, just to put that out there now. You hoist your flags on the flagpole, and then you can query the flagpole then using dynamic member lookup to just straight keep paths on the thing. It also supports nested flag containers using the @flag group property wrapper. So you can structure your flag hierarchy to be whatever you want it to be, whatever makes sense for you. We find in my day job that we tend to group things by feature or by capability, and then several levels deep inside that. So this one has nested flags, and then accessing them the same way, still dynamic member lookup all the way through, just as easy. It also comes with an auto-generated Swift, well, it's not generated, but it's a Swift UI will automatically render a UI for editing flags that you can either include, behind an if debug conditional compilation statement in your app, or you can put it into a separate app and then talk through user defaults, which is what we tend to do. But it tends to be, it's intended to make the cost of implementing a flag and making that editable as close to 0 as we can make it. So, going a little bit deeper, specifically, what happens when you write this statement? Right, what goes on behind the scenes here? So the first thing that happens is the dynamic member lookup implementation on the flagpole gets called, which looks something a little bit like this. If you've done the dynamic member lookup before, this is pretty much as basic as it gets with that. We get given the key path that you're trying to call, and we look up the key path on an instance of the top level flag container. So when you hoist your flag container, so the CocoaHeads flags one before, we create an instance of that, and then we maintain that inside the flagpole. But we can, when it comes to lookup time, we can just pass that through. But the complexity here is how we actually create that flagpole. It's quite hacky, the flag hierarchy, and it's quite hacky, to be fair. It looks something like this. Now, seasoned people in the audience are going to notice the first line is problematic to begin with. But we use a mirror to iterate over the flag container to find all of the flag property wrappers or flag group property wrappers inside that flag container. And then we decorate those with an object that conforms to a protocol that we can use to look up. So basically what happens is, and this will go all the way down the flag hierarchy, right? So if you've got 300 flags in 50 types, it's going to take a while to do that. While being, hundreds of milliseconds, but not quick at all. So what actually gets decorated is normally the flagpole. So each flag property wrapper gets a weak reference to the flagpole, so we can use it to look up its current value. This is quite painful. So who can tell me what's really wrong with this approach? Anybody want to have a crack at it? Even the person I planted in the audience and fed all the information to doesn't want to answer. No, that's all right. So Mirror is a debugging tool. It's intended to be called by LLDB when you're in the debugger to dump an object. It's not intended to be called at runtime in a release build in your app. It's not what it's for. We try to mitigate that a little bit, because it is quite slow. It's not performant code. We try to mitigate that by doing it once on init. So we walk the whole flag hierarchy on initializer. We cache those values, so we don't have to do it again. But it's still a performance penalty involved in that. Right, so now that we've walked the hierarchy and we've got it, let's go back into this one a little bit, all right? So remembering that the catering value is at flag group var catering, right? So when you're actually calling flagpole.catering, you're calling the wrapped value of that property wrapper. So just want to make sure that we're doing that because that's an important thing to know. And then the flag is another property wrapper, right? So we're calling the property wrapper.wrap value on that as well. So we're walking down the tree looking at that. So you can actually go into the final one. When you get to the flag using dynamic member lookup and calling that wrapped value, all we're doing at the end of the day is because the flag knows its key, which is just a string version of the key, we can then go all the way back to the flagpole where they started, which has the authoritative list of all of the values from the different flag sources, and ask it for the value. And if it doesn't have one, it returns nil, we go with the default value that we have configured. So one last bit, which is important context. We support taking snapshots of the flagpole. I couldn't come up with a very good flag terminology one for this, so we just went with snapshots. It's a point-in-time look at what's like. It's a snapshot. I don't know how to explain a snapshot. It's literally, as soon as you take that, we walk the entire flag hierarchy again using the cached mirror, but we still have to walk the whole hierarchy. We grab the current value at that point in time, and we put it into a dictionary that you can then use to work with. So we guarantee you that for the lifetime of that snapshot, the values won't change. Whereas if you're calling on the flagpole and one of your flag sources, so it supports updates from user defaults, you can override with user defaults from remote flag tools like Launch Darkly, all those sorts of things. If one of those changes, like there's no guarantee that if you're looking up from the flagpole of what the value is going to be. But Snapshot gives you that point in time guarantee. But yeah, again, when you've got 300 flags, taking a snapshot all the time can be quite repetitive because you're asking user defaults for the value of those 300 flags, you're asking your remote flag provider the value of those 300 flags, and then you're also looking up the default value for those 300 flags. Now, part of the problem is the snapshots are the core of Vexil. When we do publishing, we do them based on snapshots, all of those sorts of things. So it can get quite heavy when things change. So that's one of the other things that we're trying to fix. And the other hidden catch is that these are typically structs, so they're value types. So you can end up with a lot of synthesized initializers and other code being passed around. And because we're initializing it as soon as the flagpole starts, that value type is then copied repeatedly into every snapshot. And that's the whole hierarchy. So if you've got 50 flag containers, that's 50 copies every time a new snapshot is made. And part of the reason for that is that things like copy on write are not automatic. They're things you have to build support for. So that's been a gotcha for me. Oh, thank you, Pat. I forgot about that. That's something that I keep forgetting every time I reach for a nice lightweight struct, that it's going to get cranky if you have to end up making it quite big and you end up doing a lot of copying. So we have mitigated that by actually implementing copy on write within Vexil for all of our flags to get rid of that memory overhead. But it's still stuff you'd rather avoid if you can. How close did we get? 5 minutes? All right, cool. Red light? Shit. Thanks, Pat. All right, so let's make some macros. Now, the first thing I want to do is a shout out to one of my colleagues, Keith Bauer. We both, when macros came out, or in the WWDC talk, and even before that, when they had Swift Evolution proposals came through, we both had very similar ideas for how we would actually update Vexil to support this and get the benefit from it. But Keith took it a whole lot further than I did, and as a result, we got a much better thing out of it. Much better end result. So what are we trying to do with these macros, right? So our flag container is a struct. Things get copied around quite a lot. We mirror that. That's not good. And we do decorating on that. So we pass the weak references to the flagpole around everywhere. We can replace all of that with a flag container macro. Ditto, the @flag_group property wrapper is actually a very, very simple macro, and the flag property wrapper is a very, very simple macro. And we'll go through with this how we actually came to those. But I won't go into the detail of the other ones that are there, just for time's sake. I don't think you want me standing up here for 40 minutes talking about things. But part of this rewrite as well means that we no longer publish snapshots of things every time. So when a flag value changes, we don't re-snapshot the whole flag hierarchy. We just pass the initialized objects around. It's all built on async sequence now that that's a thing and that's actually mature. And we're doing a vexillographer rewrite as well to make it actual nice code. Because when that was written, that was Swift 5.5, and existentials didn't exist. Type erasure was a pain in the butt. So it's a great chance to go through and redo all of that. And Pat's doing that. No pressure, Pat.
Yeah, I'm feeling it now.
All right, so let's go back right to the beginning. So the big one is the flag container. This was the big challenge, but it actually ended up being a lot simpler once you boil it down to the nuts and the bolts. What we were trying to do is walk the flag hierarchy and decorate everything. The reason we did that is because we couldn't get the client to have an initializer that did what we wanted to. But with a macro, you can specify all of that. So how we actually went about designing this is exactly the same as we would have done this before macros. We wrote the code by hand to start with. We wrote the protocol, we wrote everything, how we would write it if we were doing it normally. which means for every flag container, we added an initializer, we added a couple of stored properties, that sort of stuff. And then you look through what that looks like and you work backwards into the macro from there. So if we wanted to remove the need to walk the flag hierarchy and decorating it using Mirror, then we can do that by moving those functions actually into the client implementations, where you wouldn't do that with a framework beforehand because you're basically asking the client to do all of the work for you. Like, why do you have a framework if you're just going to copy and paste everything into my code? That doesn't work so well. But we can provide a macro that does that now for them, and they can just opt into that behavior. If the flag container has an initializer, and it has a implementation of the visitor pattern, which is fairly standard, then we can do away with Mirror. We can do away with decoration. We can generate conformance to this. We can generate stored properties, and we can generate everything that we want to go with it. So how that actually looks like, we've taken off the manual conformance to flag container that was on the old one, and we've replaced that with a flag container macro. And we'll step through how this actually looks. This is the only change we've made that's not source compatible with the old one. Obviously, you can't take a protocol off and replace it with a macro without making source changes, but for the rest of the changes, they're all source compatible. So this is what we generate. You don't need to run Mirror if you can just pop your flag lookup value straight onto the and the key path to the flag straight onto the client type itself. So we can just generate that. So where we used to have to walk the whole hierarchy, we're now just getting it to initialize. So it's actually no more painful than doing an initializer and pass in the first place. So the initializer means, so now that we can create these structs anytime we want to, we don't incur the penalty from running Mirror and decoration anytime we create these structs. They're incredibly cheap to actually produce. We're not copying anything around anymore. We create a one-time instance of it. So we pay the allocation, the heap allocation cost for that you would normally anyway, but you avoid the copy. And because we no longer need to keep a strong reference to the flag hierarchy that we've initialized, we no longer need to worry about retain cycles. We can just create these when we need to, have them take a strong reference to the flagpole, and then just go. The other thing that we do is we generate the implementation of the visitor pattern. So that includes, so when we ask it to walk through each flag container, so when you're taking a snapshot, for example, that's just a visitor. The visitor goes in, the visitor is told when we start a group, the current value of any flag that's inside the group, and then it visits any nested groups that are inside that container. And then obviously it closes it off at the end. So the visitor is basically a delegate that's told the value of everything inside the structure. You can, from the visitor side, control how much of that you see. If you get everything you need early, you can back out of it. So just generating, the flag container and these two stored properties removed over 50% of the code that was in Vexil in the first place. Because all of the mirroring went away, all of the caching and mirroring went away, all decoration went away. Suddenly we're dealing with normal types that we could just initialize when we needed to. And you'll see a little bit of that on the next one. And that's it. No, just kidding. I spent 10 minutes setting up the context for that. So we probably should talk a little bit about the other macros too, right? Even though they're basic, there's still a bunch of challenges that went in. But you'll see how simple the flag and flag group macros became once we decorated stuff with the flag container macro. So let's look at those. So this one was probably the easiest one to do. And I say that with a great big asterisk, and you'll see why in a minute. The actual generation of code for this was super straightforward. This is actually as far as I was thinking of going with my initial rewrite, and it was Keith that took us those extra steps into the flag container and everything else. So in the current version of Vexil, this is a property wrapper. So obviously that means it's a struct class. I think it's a struct from the top of my head. It's keeping all of the properties on there. We implement copy on write for this type, so it does it with nice semantics, but it still does it. This is now a macro. But from a source perspective, it's exactly the same. So you can swap upgrade versions of Vexil and you wouldn't have to change any of this because they're backwards compatible. But I do want to look a bit more at the declaration of this one, because this one has, unlike the other one, this macro takes arguments, and passing arguments into a macro is a gigantic pain in the butt. So I'm going to complain about that now for the next 5 minutes. Yeah, so the problem here, right, is the compiler doesn't pass your macro implementation, grab those values and pass it to your macro. It can't, because the compiler needs to run your macro in order to compile that code. So you've got a nice loop, like a catch-22 there, which means that all they do is pass through to you the declaration in as an abstract syntax tree, or an AST inside Swift syntax. Passes the declaration through, and you need to pass it and process it yourself, which you can do. And anybody that's played with Swift syntax or macros knows how much of a pain in the ass and how many different variations you need to support. So I will get into a couple of takeaways from this, but we'll just go through what that actually looks like. So the declaration I've got at the top there, @flag, we specify a default value and we specify a description. The syntax tree that we get back is underneath it, and you can see that we have to go into the attribute syntaxes arguments property, and then we have to literally walk those arguments and look at the labels to figure out which argument is which. Like, we know the compiler will not let them do it in the wrong order, because if you did, this will get a compiler error, but the compiler still gives it to us without any of that information in it. So we still have to walk it manually. We still have to redo all of the error handling that the compiler does for us. You know, if they omit the default parameter or they spell it with caps or something like that, we still have to handle all of those cases, which is a pain in the butt. So we look at the first argument there. We can see the default label, so we know it's the default value. This is the easy one because we only really care about what's in the expression. And when it comes time to actually generate the code, we can just take that existing expression and insert it straight into the generated code. We don't have to do any processing of it. For the second one in that declaration, it's the description. But when it comes in, like, we could accept any string value. So there's no guarantee it's going to be a string literal. It could be a variable that happens to contain a string. It could be an integer that the compiler is just sending us anyway for whatever reason. So that's why on this one, the description is a static string, because it makes it that much harder for somebody to try and pass in a variable at runtime, and much more likely that we would get a string literal. Because at the next one, when we actually get to the code that passes this, we assume it's a string literal and we throw an error with a diagnostic if it's not. But that's something that we have to do ourselves. Swift doesn't do that for us. Yeah, so that's my tip for this one. If you're trying to pass arguments, use the type system to narrow down what the developer can put in there to try and make it more likely that they're going to do the right thing or what you actually support. And if they don't, emit helpful diagnostics, because at the end of the day, I guarantee you it's going to be you 2 years from now wondering why the hell this code's not working. And be like, past me wrote a terrible diagnostic, that's why. So the other example, I keep jumping around. The other example, the second parameter here, the key strategy, we're working with an enum. So I've cut that out here. It's a nice enum, very straightforward, and in the normal code, that's what it looks like. It's just the flag key strategy, has some options on it. Nice and easy, but we can't access this enum in the normal code from our macro, because the macro code runs inside the compiler, it doesn't run inside your app. So you have to have a second copy of it inside your macro code. And then you have to pass it manually. So you don't get told that this is a nice enum. You get told that it's I'm not even going to try and guess what that was. If it's a member access expression syntax, it was probably a member access list, was the type that we got given. And so you have to pass it manually. So you're literally looking at the declaration, which is on the first line up the top there. So the dot default bit is what we get passed in, and you have to process that manually. So we grab it, we do string comparisons, because everybody loves string comparisons, and then we initialize it that way. But you not only need to handle, there's 100 different ways you can write dot default there. 100 different ways you could do that. You could write dot default, you could write the full type dot default, you could put it into a variable and put it through, and the compiler will be happy with all of those, but your macro code won't be. So you've got to handle all of that. And so while you can try and make it as nice as possible, a user experience or a developer experience to actually use your macro, the more you do that, the more complexity you're going to support, which is great. It's not so bad. I cut it out because it was too many lines of code, but trying to support the custom key and the custom key path means you need to process what's inside the whole, arguments, and that could be multiple ones. Again, you're relying on the compiler to help you, but you're still processing it all manually. And that reminds me, actually, I should make those static strings as well so that we don't, we expect them to be string literals. Okay, so back to this bit. The hardest part of this macro is the processing of the macro parameters. The rest of it's really trivial. So this is actually what it looks like. We've replaced that whole property wrapper and all of its garbage with an accessor, a getter, that calls the flag lookup stored property that the flag container macro puts on there. And we do all of the work that a 100-line property wrapper does in 1 line of generated code. Well, I think 3 lines because I wrapped it because make it nice on the slide. And that's it. That's all it does. Like, it's really, really simple once you actually you can start working with the types directly. So just to highlight, you can see where our macro parameters have ended up in the generated code. The default value that's false on there ends up on the other side of the nil coalescing operator. The key strategy ends up as part of our flag key path creation, and we use a transformed version of the property name as part of our flag key. And that's all done as part of the macro, so this is done at compile time. This is not a runtime operation. Makes it much faster. It also generates a wigwag. Now, what is a wigwag, you ask? Or you're asking yourself why I'm continuing to name things really stupid. Could go either way. This is a wigwag. I've definitely leaned too far into the flag terminology, but it's too late now. I'm invested, and we're just going to keep going. Hopefully nobody has to look at this type too much. I guess there's probably a caveat there too. Vexil, the name of the project, is short for Vexillology, which is the official name for the study of flags. So there are vexillologists out there who study flags, and this is a shortened version of that. Per the definition there, a wigwag is an old type of flag signaling that's not used so much anymore, but it's basically, depending on how you wave a flag, changes the meaning of what you're trying to convey to somebody else. So that sounds a lot like, changing flag values that we might emit from a publisher, so why not? That's good enough. But back in Vexil, wigwags have 2 purposes. They include the rest of the flag's metadata, so that generated UI code can get all of the information it needs to generate that UI, as well as the descriptions, all of that sort of stuff. And it is also the source of real-time flag value changes. So much like a waving flag, as the flag values change, a new wigwag is created. Well, no, the wigwag emits the next flag value. And unlike the old one, this supports both async sequence and publishers. So you can scribe to whatever way you want, and the wigwag will tell you when flags change. almost at the end now. So just for completeness, I will include the @flag group macro, but it's pretty much identical to the one that's in the flag macro. The parameters are slightly different, so the code is slightly different, but they're otherwise the same. The main negative here is where the old property wrapper included, you could have a generic on the wrapped value. So you could add inheritance clauses to that. So you could have a nice clean error message that if you tried to wrap an unsupported value, it would tell you that it's unsupported. Unfortunately, when macro is called, we're not told anything at all about the inheritance clauses of the type that we're attached to, unless you're like an extension macro or a member macro. For an accessor macro, it doesn't get any of that information. So we can't tell whether or not catering flags is a flag container. The only way that happens is in the generated code. So the error message ends up being buried in the generated code, and you can only find it when you expand the macro and then realize that it's not quite right. So there's definitely a developer experience step back there, but I think overall it's totally worth it. And that's it. This is actual end of the one. This is not, as I mentioned, it's not quite published yet. I'm waiting on Pat to, no. I haven't, there's still some, there's still some optimizations I need to do. Like if you go back to this one, here, for example, every time we walk the flag hierarchy, we're looking up the value at that point. So it's still just as bad when you take a snapshot. It looks up everything, whereas that should be probably an auto closure that's only executed if you actually care about the value. So stuff like that still needs to be done. But yeah, probably a month or so away, I think. So was there any questions?
When do I have to get done by?
Yesterday, Pat. Yesterday. No, there's literally no rush. Like we haven't even gone Xcode 15 native at work yet, so nobody knows this is a thing. Yeah, they're probably watching now, so this is going to be...
I didn't realize there was a microphone. Hi. I was curious if you use this flag system solely for sort of local flags and local configurations, or if you're able to import like a remote A/B system into the flag.
Yeah, that's what it's designed for.
Ah, cool.
It's designed to, you do it as you need it, right? So you create your flag in code, and that flag has a default value in code. If you're using the generated code from Vexilographer, you can work with that to do local testing. But you can also hook it up to remote flag systems like we use LaunchDarkly. You can use Google Remote Config and other. You can use a JSON file on a web service. Like it doesn't really matter where your values come from. But you only need to add them to that when you need to control them from that, right? The implementation of a flag value source is really a method. It's like get the value for this flag, this type, and it returns an optional. If your remote system doesn't yet support that one or doesn't know what that key is, it returns nil. We move on to the next one. So yeah, you can definitely do that. Oh no. It's a tricky question coming, I'm sure.
With the work done with macros, would you be able to get a publisher out of the observed flag?
Sorry, could you ask the question again? Couldn't quite hear that.
Would you be able to observe on changes on flags from the client side with macros?
You'd be able to generate the code that either admits or subscribes to that, yes.
Okay.
Not sure the context of the question.
I just want a publisher out of a flag.
You can, yeah, so that's this bit, right? It generates the wig-wag is the publisher, yeah. It generates the $ is scheduled version of it. Okay. So when you're using your key path, you just swap if you want the publisher version, instead of pushing the buttons, I should jump. How far back was this? Yeah. When you're using this version, if you just do $vendor, okay, you'd get the publisher for that. Yeah, but yeah, so the macro will generate both.
Okay. Thank you. As a library maintainer, are there forward compatibility implications of using macros like this?
No. No. So the same rules around forward and backwards compatibility still apply. Macros are additive, so as far as ABIs are concerned. If you are distributing binary XC frameworks for it and you're committing to that sort of stuff, you need to pay a lot more attention to your use of final and frozen enums and all of those sorts of things. But if you're only doing source-based distribution, which is what 90% of Swift packages are, no, it's no more complicated than shipping normal code.
Thank you.